Hi, this is a Team Triple H. We did the final project on toxic comment classification. Nowadays, many people experience online harassment, and after this user responded, they stopped, reduced, or changed online activity. This data suggests the possibility of toxic comments stopping people communicating in cyberspace and eventually decreasing the usage of online service. It strongly suggests the need of a toxic comment classification. To do this, we use data from Kaggle, including the comments taken from Wikipedia with 6 different hate speech categories. We found that about 90% of the data is not labeled with any toxic categories, which indicates the need of including the process of classifying this clean data under separated category. Moreover, with word cloud, we found that certain text consists of more than one word are double counted with different order. Also, with the even distribution of frequencies among different tokens, it is reasonable to use top K sampling for this project. Therefore, with the information gaining from the previous analysis, we used stop words padding, top K sampling, and integer encoding for the pre-processing of the data. With this pre-processed data, 6 different neural network models are implemented. Mainly they are LSTM, CNN, and GRU. In order to test these different models, we used an F1 score that was computed through validation set to evaluate the performance of each model when we tuned the hyperparameters. Also, we used an AUC score obtained by submitting the predicted output on test data to Kaggle. LSTM is implemented in 3 ways and results are shown here. To improve the performance, we implemented bidirectional LSTM and it indeed shows slightly better performance than the general one as expected. With CNN model, we got the F1 score of 0.99, but only 0.5 for AUC score, suggesting the possibility of overfitting of the model. Therefore, this model should be modified to prevent overfitting for the future work. With GRU, they all show F1 score closer to 1, which strongly suggests the possibility of overfitting. Especially because of this, by using bidirectional model, it shows a slightly worse performance for predicting output on test data, which could be due to overfitting. However, they showed a better AUC score compared to previous CNN model. With 6 different models, we got this result. Therefore, by finding the best model among 3 different categories, LSTM, CNN, and GRU, we compared the performance and found the reason for it. The big gap between F1 and AUC score suggests the possibility of overfitting. Considering this, nearly half of the F1 score for AUC of CNN model indicates the severe overfitting problem. Moreover, with F1 score of GRU, we suspect the overfitting, but it shows a pretty good performance with AUC score. Therefore, it suggests the possibility that by controlling the overfitting, GRU can actually show the better performance than bidirectional LSTM model. Among these models, bidirectional LSTM shows the best performance considering both AUC and F1 score. Unfortunately, we cannot conclude LSTM is better than CNN or GRU because in order to compare the effect of architecture, we fixed the hyperparameter for the baseline. Therefore, tuning these values could actually improve the performance. For the future work, in order to improve the performance and accuracy and find the best model for this task, we can possibly do the following. By doing this, we can finally find the optimized model for different neural network architecture and compare to find the best one. Thank you.